Hello students, this is Vijay Janardhan Ushir working as an assistant professor in Department of Chemistry. This is the second lecture of our physical chemistry course for the surface chemistry chapter. In the last lecture we have started our second chapter, that is surface chemistry, and this is the second lecture for the surface chemistry. In the last lecture we have studied what do you mean by the surface chemistry, what do you mean by the adsorption, what do you mean by adsorbate, adsorbent, all these things, and what is the difference between adsorption and absorption, and what are the different adsorption materials. So in this lecture we will study the adsorption materials in detail. The main adsorbent used in many industries for the filtration and purification technique is a solid porous black carbonaceous material with high specific surface area. Means in the many industries for the filtration and purification technique, the adsorption material is used, which is a black carbonaceous solid porous material and having a high specific surface area, and it can be prepared from large number of sources such as a coconut shells, waste wood, peat, black ash, rice husk, lignite, bituminous coal, petroleum coke, etc. And it has a high internal surface area. Means this carbonaceous material provides high internal surface area and also high pore volume. So what is the significance of this? Which makes it very convenient to be used as a adsorbent catalyst. And commercially, the activated carbon in powdered form was first prepared in Europe in early 19th century. Means in the early 19th century, the commercially activated carbon in the powdered form was first prepared. So, what is the activated carbon? So, we know that it is the main adsorbent used in many industries for the filtration and purification technique. And what are the properties of this activated carbon? It is a solid, porous, black carbonaceous material with high surface area, and it can be prepared from large number of sources such as coconut shells, waste wood, peat, black ash, rice husk, lignite, bituminous coal, petroleum coke, etc. And it has a high internal surface area, also high pore volume, which makes it very convenient to be used as a adsorbent. Means because of high internal surface area and high pore volume, it is very convenient to be used as an adsorbent, and the catalyst supports in gas and liquid phase processes for purification and chemical recovery. Means this catalyst supports in gas and liquid phase for purification and chemical recovery. The commercially activated carbon in powdered form was first prepared in Europe in early 19th century. Means the commercially activated carbon was first prepared in Europe in 19th century in the powdered form. So, what are the different methods for the preparation of activated carbon? So, there are mainly two methods for the preparation of activated carbon. First is a physical activation and second one is a chemical activation. So, the physical activation again get divided into two types. One is called as a carbonization and second one is called as a activation. Means the preparation of activated carbon is in two steps, two methods, that is a physical activation and chemical activation. And that physical activation again get divided into two types, that is a carbonization and activation. So in detail we will study these methods for the preparation of activated carbon. First is the physical activation. So in that we will study first, that is a carbonization. So what is a carbonization? The process in which carbonaceous precursor is converted into solid char in an inert thermal atmosphere, leaving the other liquids and gases as a byproducts is called as a carbonization. Means the process in which carbonaceous material, carbonaceous precursor means starting material, and carbonaceous means carbon containing material. This carbon containing starting material is converted into solid char, means it converted into solid char or also called as a solid ash in an inert thermal atmosphere. Means inert means thermal atmosphere. the temperature is constant, leaving other liquids and gases as a byproducts. This process is called as a carbonization, and it takes place in absence of air. Inert atmosphere means there is no presence of air and at a temperature of 600 to 800 degrees Celsius. And this is the first method, that is a carbonization. So in that, carbonaceous precursor is converted into solid charge by using inert atmosphere, leaving other liquids and gases as a byproduct. It is done in absence of air and also at a temperature of 600 to 800 degrees Celsius. Second method is activation. So what is the activation? It is a series of processes in which char porosity is improved. Means the porosity of that char, solid material that form, is improved by increasing surface area of produced activated carbon. Means in the carbonization method, the carbonaceous precursor is converted into solid char, and in the activation what happens? The char porosity, the whole capacity of this char is improved with increasing total surface area of produced activated carbon. And it is not only determine its porosity but also determine the chemical nature of its surface. Means this activation method not only determine the porosity but also the chemical nature of its surface. And in this case, the activating agent, activating agent is used, it is a carbon dioxide or steam or air at high temperature, that is 800 and 1000 degrees Celsius, to develop a porous structure. Means to increase the porosity. So the main purpose of activation is to increase the porosity or to increase the surface area, and which is done by the activating agent such as carbon dioxide, steam or air at high temperature. And activation can be done either by physically, chemically or by combination of both, and this combination of both is called as a physico-chemical method. Means the activation can be done by physical method also or chemical method also, and the combination also, that is called as a physico-chemical method. So these are the two methods coming under the physical activation. First is the carbonization, second one is the activation. So in the carbonization, it is done in absence of air. The activation, it is done in presence of air, in steam or air at high temperature. So second is the chemical activation. So what is chemical activation? The raw material used as a chemical agent. Means it is a chemical activation. Therefore, the raw material used in this method is a chemical agent such as a phosphoric acid, sulfuric acid, potassium hydroxide, zinc chloride in an inert atmosphere. So in this method, the different raw materials used are these all are the chemical agents such as phosphoric acid, sulfuric acid, potassium hydroxide or zinc chloride in an inert atmosphere. The product is heated either at moderate or high temperature. Means the product is heated at either at low temperature or high temperature, about 500 to 800 degrees Celsius under the flow of steam. Means under the flow of steam, the product is heated at 500 to 800 degrees Celsius and then washed with distilled water until the pH of washed water becomes of the distilled water. Means this product is washed with distilled water up to which state, that is the pH of washed water becomes the pH of distilled water, and the yield of chemical activation method is relatively larger than the chemical activation method by nearly 30% by weight. Means the yield of chemical activation method is relatively larger than the chemical activation method by nearly by 30% by weight. And what are the different advantages? So it is simplicity, means there is no need of previous carbonization of raw material. Means there is no need for the carbonization. As we have studied in the physical activation, we do the carbonization. So there is no need of previous carbonization. Lower temperature of activation. So temperature of activation is lower, and good development for the porous structure, means there is good development of porous structure. So these are the advantages of the chemical activation. So next point is the types of adsorption and its characteristics. So what are the different types of adsorption and its characteristics? So in earlier slide we have studied the chemical activation. In that we have studied the advantage that the yield of chemical activation method is relatively larger than the, I have said here chemical activation, but it is a by physical activation method, by nearly 30% by weight. Means in the chemical activation method, the yield of chemical activation method is relatively larger than the physical activation method by 30% by weight. Means this is the advantage of this chemical activation method. So what are the different types of adsorption and its characteristics? So there are mainly two types of adsorption. One is the physical adsorption, or it is also called as van der Waals adsorption, and second one is the chemical adsorption or chemisorption. So what is physical adsorption? So in this type of adsorption, the gas molecules are held on the surface of adsorbent by van der Waals forces. Means the gas molecules are held on the surface by the van der Waals forces, and these are the weak forces and non-specific in nature. Means the van der Waals forces are weak and non-specific in nature, and it is characterized by low heats of adsorption of the order of 10 kilocalorie per mole or less, and it preferentially occurs at low temperature. Means the physical adsorption, the gas molecules are held on the surface of adsorbent by van der Waals forces, and these forces are weak and non-specific in nature, and also characterized by low heat of adsorption, that is order of 10 kilocalorie per mole or less, and it preferentially occurs at low temperature. Because low heats of adsorption is required, therefore it occurs at low temperature, and the process of adsorption is reversible and equilibrium is established rapidly. Means the physical adsorption process is reversible and equilibrium is established easily, and the process is easily reversible either by raising the temperature or lowering the pressure. Means how the process is reversed, either by increasing the temperature or by lowering the pressure. And in this adsorption layer may be several molecules thick. That is the formation of multimolecular layer. Means the physical adsorption, there are many molecules layer of the adsorbent is formed. So it is also called as the formation of multimolecular layer, and it may be found in the gases like hydrogen, nitrogen, carbon monoxide, methane, carbon dioxide, HCl, H2S, chlorine, and gets adsorbed on the charcoal adsorbent. Means these are all the examples of physical adsorption. Means the physical adsorption means the molecules are held on the surface only by weak forces, and that weak forces are called as a van der Waals forces, having low heat of adsorption of the order 10 kilocalorie per mole and occurs at low temperature. The process is reversible, equilibrium is established easily, and how the process is reversed by either increasing the temperature or lowering the pressure, and the adsorption layer is several molecules thick, that is the formation of multimolecular layer, and the examples are H2, N2, CO. These different gases H2S, Cl2 are adsorbed on the charcoal adsorbent, that is a activated adsorbent. So this is the first type of adsorption, that is a physical or van der Waals adsorption. So second is a chemical or activated adsorption, or it is also called as a chemisorption. So what is chemisorption? In the chemical adsorption, the gas molecules are held on the surface of adsorbent by the forces which are similar to chemical bonds. Therefore, the compound may be formed at the surface. Means in the chemisorption, what happens? There is the formation of chemical bond. Therefore, the compound is formed at the surface. Example is the adsorption of oxygen on tungsten at about 1200 Kelvin, and also the similarly CO on tungsten, and it is characterized by high heats of adsorption. In the physics option, it was characterized by low heats of adsorption. So, chemist option is characterized by high heats of adsorption of the order 20 to 100 kilocalorie per mole of adsorption and leads to much firm attachment of gas to the surface of adsorbent. Means much pack arrangement of gas on the surface of adsorbent. It occurs at high temperature, means chemical adsorption occurs at high temperature. It is rarely reversible, that is desorption is difficult, means the adsorbed gas is dissolved very difficultly because there is formation of chemical bonds which are not easily broken for the desorption, and to remove the adsorbed gas, the solid must be heated at high temperature and pumped at a high vacuum. Means to remove that adsorbed gas, we have to use the high temperature and pressure conditions. And in this, the adsorption layer is only single molecule thick. That is the formation of monolayer. In that physical adsorption, the adsorption layer was multimolecular thick. And the chemical adsorption is only found where there is tendency towards the compound formation between the gas and adsorption. Means chemical adsorption is only possible if and only if there is tendency for the formation of chemical bond between the gas and the adsorbent. So, next point is the difference between physics option and chemist option. So, we will revise in the difference form between the physics option and chemist option. So, we have studied what is the physics option. The adsorbent molecules are held on the surface by weak van der Waals forces. In the chemist option, the adsorption molecules are held on the surface by chemical bonds. It is reversible in nature, and chemist option is irreversible in nature because there is formation of chemical bonds. It is not very specific in nature, but chemist option is highly specific in nature. It forms multimolecular layer. In the physics option, multimolecular layer forms. In the chemist option, only monomolecular layer is formed. And it usually takes place at low temperature. That is only weak van der Waals forces. But for the chemist option, there is formation of chemical bond. Therefore, it relatively takes at high temperature due to formation of chemical bonds. Enthalpy of adsorption is very low. That is 20 to 40 kilojoules per mole. Here the enthalpy of adsorption is very high, up to 40 to 400 kilojoules per mole. And normally in the physics option, it does not involve any energy of activation, but in the chemist option, it requires the activation energy. So, this is the difference between physics option and chemist option. So, thank you. In the next lecture, we will study the third part of our surface chemistry in the third lecture. Thank you.